What is open architecture? The Gartner Group, a highly respected consulting organization, defines open architecture as being based on standards that are readily available. Some standards are available, many of them aren't, if only by cost of acquisition. There's another problem for me with open architecture. It's biased, and I don't mean that in a negative way, but it's biased toward the OEM, toward the production line. Let's talk about open architecture for the rest of us, for field services, OSP, FTTX, the total industry. The Gartner definition of open architecture and all standards in general are really important baselines, but there are limitations. One of the limitations to standards is that they're updated infrequently, every 5 to 10 years, for example. And our technology in our industry quite literally moves at the speed of light. The other restriction within Gartner is that the use of fully available technical standards. Oftentimes these standards are not fully available. Sometimes they have a cost associated with them to procure the standard and to actually write the standard. So, is it all for one and one for all in terms of cleaning and inspection, the way IEC defines it? Or are these application-specific procedures based on the awareness of specific tasks as we encounter in field services? I realize I'm pushing the definition of open architecture a little bit here, but there's a reason. Fiber optic standards for inspection and cleaning are not really based on best practices, nor are they vendor neutral. As you look at this, the standards for the end face consider it as a two-dimensional structure. But as you see here in these images captured with the RMS-1 Mark II, there's far more to the end face than 2 dimensions. It's obviously 3 dimensions. So open architecture inspection and precision cleaning considers all deployments, all sectors of the markets, beyond minimum requirements to an open architecture best practice of commonality and science. So we take a look at the end face as defined by IEC, and this one is an SC 2500 microns. That circle is maybe 150, 175, 200 microns. There's far more to it. So what we want to do is we want to expand the end face. We want to go beyond the limited field of view. And this is important because field services encounters far more than what the production line does. As an SCCA competition designer and builder, one of the very first things I learned was do it right the first time. That was after many times of not doing it right the first time. And this included such things as selecting SAE grade 8 bolts and nuts and washers, and occasionally NAS standard bolts, and SAE grade lubricants. As our industry is gravitating toward an open architecture stance for transmission components, I promote the idea of procedures that have functional commonality in the same open architectural way. You know, it's funny, some have actually claimed that cleaning these surfaces isn't necessary, but over the years, insertion loss, reflections, misalignments, if only they were a minor concern, are still a concern, and saying it's not a problem sends the wrong message. So let's do it right the first time. How do we clean now? What are the procedures? I'm introducing two terms here, primary and secondary contamination. Primary contamination may be present on primary surfaces as defined by IEC 61300 3.35 revision 2. Other standards may not have updated to the June 2023 standard. So that is why I continue to show A, B, C, and D as the primary surfaces. Secondary contamination is defined by natural sciences. These are the remaining three-dimensional surfaces. What we'll see in the remainder of this presentation is how both primary and secondary contamination on primary and secondary surfaces influence transmissions of all types. Secondary contamination is everything else. This is debris and contamination that is typically unseen by existing inspection devices. However, it is debris that can migrate and can transfer into the primary contamination zones. I break inspection into four classes. One isn't better than the other. Each one has a specific purpose. Class 1 is the traditional probe and monitor. 200, 400, this particular one is about 130x, has a wider field of view, and begins to define the total horizontal end face beyond IEC 61300 3.35. Class 2 is the wireless auto detect that follows IEC 61300 3.35. If you are working with that standard, this is a marvelous machine. Class 3 is the direct view. Some claim that these are useful for field service. My concern is that using this on a direct laser might cause eye damage. These types of inspection are best used for quality control incoming and outgoing. The latest is Class 4. This is digital photography, still in motion imagery, captures the connector surfaces, end face to adapter, alignment ports, alignment sleeves in digital color. So, to coin a phrase, it's different scopes for different folks. If you want to follow IEC, there are some wonderful scopes available for you. If you're doing basic cleaning and inspection, there are also some spectacular Class 1 scopes. If you're doing jumper QC, your Class 3 might be the best choice. If you want to do R&D, if you want to train, if you want to expand the way we consider the connector into 3 dimensions, then they're Class 4. Select the one that works the best for you. Over the years, since the introduction of Cleatop in 1998, 1999, the industry certainly has fostered a wide range of cleaning products. And as you can imagine, each one of these manufacturers claim, mine is the best. The reality is that some of these options are just not suitable for precision cleaning fiber optic surfaces. Let's start here. Compressed gas dusters and compressed air. Compressed gas dusters simply will not remove, for example, a greasy fingerprint. You can try it, take a look, it won't work. Compressed shop air, once again, no matter how well it's filtered, simply won't remove that type of debris. The second type is the optical lens cleaners. Optics is one of those words, I call it a fat word, P-H-A-T word. Many meanings. Optical lenses, such as microscopes or eyeglasses, are very, very different than the precision surface of a fiber optic end face. Anything that says that it will clean an optical lens is not suitable for cleaning a fiber optic end face. And then finally, solvent selection. Isopropyl alcohol is still commonly used. Isopropyl alcohol is fine for fusion splice prep, but the solvent itself isn't capable to remove the different types of debris that may be encountered in the fiber optic deployment. Remember, what we're looking for is open architecture, something that's universal, something that creates a common denominator, and isopropyl alcohol simply isn't that solvent. It may be that precision cleaning isn't about product choice, but rather how the product is used. Is there a process that makes all of these tools work better? So, how do we clean the surfaces now? What do the standards teach us? But what does the science say? Open architecture, vendor neutral, best practice is about clarity. And already there's very little clarity here. There's dry cleaning, wet to dry cleaning, combination cleaning, solvent transfer, and in the early days there was a fifth one. It was called wet cleaning. Clarity is always best practice. What is the best practice that brings together one common procedure for the OEM and field services? Let's take a look. As a member of the production line community, you're well aware of static field. Your benches are likely treated with special chemical treatments, and surely your technicians are grounded. However, for the field service group, it's a little bit different. Oftentimes we're not aware that processes like dry cleaning can create static field accumulation. Static field contamination is not considered by existing IEC standards. And this is what it can look like in field service. Could be an eyelash in the center. That is a tribocharge dust. And on the far left, that's a piece of lint. Again, field services is different than production line, but there is nothing keeping an eyelash from being trapped on a zone 5 ferrule on the production line as well. It's become increasingly common for network designers or area managers to write inspection and cleaning procedures into documents or work orders. This is because while the existing standards are invaluable, they are still minimum requirements, and many operators will self-standardize to a higher level based on specific installations or perhaps their specialties. The fiber optic connection on a cell tower, or on the top of a smokestack at TVA, or perhaps in the middle of a desert, are all different, and they require application-specific instructions. Furthermore, and we know this from when we do any common task, a moistened wiper always works better than a dry wiper. Very difficult to clean a windshield with a dry wiper. Very difficult to clean your LED screen with a dry wiper. Very difficult to do the laundry just with soap alone. Adding a moisture always helps the cleaning process. If we met in a garage or OSP or an SCTE or Bixie event, we would have been talking about wet to dry cleaning. But in those days, it was directed to my employer. And it was called combination cleaning. Combination cleaning was devised because what we wanted to do was to follow what the Cisco series directed, and that was a worst case environment. So in these times, wet to dry cleaning has evolved without the definition that we had back then. So let's talk about wet to dry cleaning. When we say wet to dry cleaning, what do we really mean? This end face is contaminated with perspiration. It was pretty hot here today, and my hands were oily, and I just simply touched the end face. So what you're seeing here is perspiration, and what we're going to try to do is to clean it with a high purity IPA wiper. And in doing that, we're going to follow techniques that I've seen in the field. We take the end face either through a wiper, or maybe we've pumped solvent into a lint-free wiper. And we simply draw the end face through this IPA. Might do it straight, might do a straight line, might do a figure eight. There's no definition. What we're seeing here is flooding, and that's pretty obvious. But as we go to dry it, we find that we might get it dry within the field of view. This Optic 9600 has a scroller, so what we're seeing here in the field of view is at 425, 426x, but as we scroll out to the side through the whole zone 4, we see excess solvent being flooded from the vertical ferrule that I call zone 5. So wet to dry cleaning without clarity of the definition could very well be the problem.
Whenever you're using precision solvent to clean a fiber optic connection, always use it in moderation. Never dunk a probe or a swab tool into a pool of cleaner. Always transfer. Tip the end of the swab, tip the end of the probe into a small amount of solvent. It's best practice.
The secret? There's got to be a secret. Well, the secret is based on science. Debris is attracted to moisture. We know this. Even a Swiffer that started out as a dry mop now is moistened. However, for the microsurfaces that are fiber optics, we can use too much solvent, or we can use the wrong solvent, or we can use the wrong tools. The science is in product selection and how the products are used. Existing standards speak to dry cleaning as the first procedure. That's great if you're on a production floor and you know what the debris is going to be. Field services are harsh environments. They're different. So a worst case open architecture vendor neutral procedure, that's standard, is best practice, and that's what I advocate. If I can help you develop a program for your operation, please let me know. Let's talk about precision cleaning the assembly, that is the jumper side cable, the backplane cable, and the alignment sleeve. So let's do some definitions here, okay? This is an end face, and it is pictured in the alignment sleeve. As you see, the actual end face is clean per the IEC standard. The black dot in the center is the core, and that total horizontal surface, which by the way I term as zone 4, that total horizontal surface is clean, but as you look at the alignment sleeve and the zone 5 vertical ferrule, they're contaminated. On the other side, there is a zone 5 interface, that's the adapter shell, and then the zone 5 alignment sleeve. All of those are contaminated and subject to cross-contamination. What are the tools? The 2.5 millimeter probe tool tape actually measures around 2 millimeters. It's a rectangular cleaning a circle, and as you see, it's actually the edges of that cleaning tape that, even though that rotates, the edges are what's doing the cleaning, and they absorb the soil. The same is the same for the 1.25. It's smaller. If you're cleaning per the IEC standard, then the 1 millimeter probe tool thread meets the standard, but certainly it may not be as adequate because it's smaller. If the adapter alignment sleeve is contaminated, then that smaller thread absorbs and oversaturates with contamination. There's a lot of science to this. Best practice is the 2.5 millimeter swab tool. This tool cleans with two different surfaces: a foam surface that touches and cleans the alignment sleeve, and a bullet-shaped tip that passes through, doesn't contaminate itself, and cleans the backplane. All of these surfaces, really best practice is to moisten them, to attract the debris into the cleaning surface. Each one can work, just be aware of the differences. My name is Ed Forrest, and I've been studying cleaning procedures since 1999. If I can help you with your specific problems, create a training program customized for your needs, please don't hesitate to let me know.